Hi everyone, and welcome back to our next video on AC circuits. We are going to take a look at something called rectification, and it involves a circuit that you'll find in a whole bunch of places in your home. For instance, a charger for your phone or a charger for your laptop. There's a rectification circuit in that. So let's take a look at how this works. So what is rectification? Well, remember that alternating current or AC power is the most common form of electric power produced in North America and in the rest of the world. AC power is used in our homes to power devices like ovens, our refrigerator, and air conditioning units. However, a number of devices in our homes run on DC power. So what devices in our home run on DC power? Well, think of all the devices that have a rechargeable battery that needs recharging. For example, your laptop, your tablet, your phone, just to name a few. To charge these devices, we need DC power. So we need to be able to convert AC power to DC power. This is called rectification. What devices in your home allow you to do rectification? In other words, we need to take AC and we need to convert it to DC. And you can see an example of a DC plug on the right. Well, in terms of a graph, we need to go from AC power, which is shown in blue, and we need to convert that to DC power, which is shown in red. So what allows us to do this? Well, like we said, it's a rectification circuit. And you will find these in charging blocks for your laptop and your phone, like the ones on the left. Sometimes we call them AC-DC converters because that's what they do. They convert AC power to DC power. To do it, the circuit typically looks like this. It's called a bridge rectifier circuit. And we have a AC input here, and in the circuit we have 4 diodes oriented in a specific way, and then we have our DC out or V out. This is the circuit without a what we call smoothing capacitor, and here's the circuit here with a polarized capacitor as a smoothing capacitor. And we're going to take a look at how this circuit works. So let's take a look. First thing, we are going to take a look at one type of AC-DC converter. This is one here. This, as you can see on the label here, has an input voltage rating of 120 volts AC, and its input of 60 Hertz will produce an output of 12 volts DC, and it's rated for a maximum of 500 milliamps. Here is our DC plug. You can see it actually shows the polarity on there. The outside metal is the actual ground or negative, and on the inside it's difficult to see, but right here has a little plus sign, so that's the positive side. If we open this up here and take the back off, we can see what's in this rectification circuit. This big silver part here is the transformer, and you can see that here is our 2 wires that come from our plug in the wall. So there, and that comes into this device here, which is a transformer. We're going to talk about transformers later on and how they function. If we pull this circuit apart, we can see that it's really simple. We just have this capacitor here, which is our smoothing capacitor, and then we have our 4 diodes. Those diodes, as mentioned, have to be oriented in a specific way, but that is a bridge rectifier circuit and what it looks like. So let's go into our simulator and let's take a look. So first of all, we're going to start with a really simple rectifier circuit. This is called a half-wave rectifier circuit, and this configuration only utilizes the positive or forward cycle of the sine wave. Note that in this half-wave rectifier, there is only one diode in the circuit, and that's positioned right here. And then we have our load here, which is a 1 k ohm load resistor. Notice this is a forward bias diode. So what happens when we turn on our function generator is the forward or positive part of the AC cycle will be able to go through the diode. It will be forward biased. But the other side, when it tries to come through here, the negative side of the cycle, it's going to come to the diode and see that it is reverse bias. So it will not let current flow on the negative side of the cycle, only the positive side of the cycle. So when we start our simulator to take a look at this and see what it looks like, you can see that what happens is only the forward or positive side of the cycle actually shows up across the load. This is normally where we would see the negative side, but because the diode is forward biased in the positive side, we only see it on this side here. So this is what we call a half-wave rectifier because we only see half of the wave. So that is a half-wave rectifier. Let's take a look at a half-wave rectifier, but this has what we call a smoothing capacitor. So it's the same circuit, same setup, except across the load, in parallel with the load, we have a smoothing capacitor. If I click on this here and take a look at the characteristics, the one that we have here is a 1 microfarad capacitor. You can open up Tinkercad and try different values to see what happens, but let's run it as it is. So you can see here right now that it looks a lot like what we had in the last circuit, and that is because of the size of the smoothing capacitor. Right now what's happening is the capacitor is actually too small and it's discharging too quickly. What we want to happen is we want the capacitor to hold the charge so we don't get a large peak and then a low voltage, large peak and low voltage. We want to try and smooth this out. So if I stop the simulator and let's go in and make this 10 microfarads, let's make it a little bit bigger and start the simulator. You can see that now it does go up to the peak, but as it discharges in a logarithmic fashion, it doesn't go all the way down to the bottom as it did before. If we stop the simulator and let's go into the capacitor and let's make it 100 microfarads, we'll make it even bigger this time and start the simulator. You're going to see that there it actually holds the voltage more steady or stabilizes the voltage in between the peaks. There is some discharge here, but not as much as before. So the smoothing capacitor is really important. That is supposed to stabilize the DC voltage on the output. So let's move on and take a look at the next circuit. This is our bridge rectifier circuit, and what we want to be able to do is utilize both the positive and negative cycle of the input sine wave. In the past circuit, we only utilized the positive side of the cycle. If we want to utilize the positive and negative, we're going to use a bridge rectifier. And a bridge rectifier has 4 diodes down here as shown below. The top 2 diodes are forward biased and allow the positive cycle current to flow, and that's going to come through the orange wires. The bottom 2 diodes are forward biased and allow the negative cycle current to flow, and that's going to go through the blue wires. So let's take a look at how this circuit functions. So if we start our simulator, remember that in this case here, we don't have a smoothing capacitor just yet. You can see that now we have the forward or positive cycle, and here's the negative cycle. Here's the forward cycle, and here's the negative cycle of the sine wave. So now we're utilizing more of the input AC sine wave, and that's what a bridge rectifier does. If we stop this simulator, let's take a look at what this looks like when we add the smoothing capacitor. So in this case here, we've added this smoothing capacitor. If we click on this here, and let's make this 1 microfarad, and let's try this same simulation with a smoothing capacitor. You see that now it looks a lot like it did before. But if we change the value on the smoothing capacitor and make it 10 microfarads, you're going to see that now again it holds the voltage and it doesn't allow it to go down to 0. Still though, there's too much fluctuation between the lowest point and the high point. Let's stop the simulator and let's change this to 100 microfarads and start the simulation. And again, now you can see that it is a more stable DC output voltage. That is what we want, so that we can have a DC output that's more constant. We can use that to, like I said, charge our phone, charge our laptop, or whatever circuit we have. Note for this circuit here, for the simulator, we did have to do something with the ground wire here. So if you try this circuit, we had to put the ground wire in here to make the simulator work. So just make a note of that if you are trying to build this cycle. We did this for a simulation to see how a bridge rectifier works. We won't talk too much about the grounds in this case here. It's a little more advanced for this lesson. But I highly suggest you open up Tinkercad and try it. That's it for this video, everyone. I hope it was useful and informative. Thanks for watching. See you next time.